6.4, Temperature and Volume, Charles's Law. Have you ever seen hot air balloons as they begin? Have you ever wondered why it's called a hot air balloon? Well, hopefully you will be able to see in this section what the relationship between temperature and volume is, so that you can see some practical applications, one of them being the hot air balloons. In Charles's law, the Kelvin temperature of a gas is directly related to the volume. We're assuming this is when pressure and the amount of moles are constant. Now, when the temperature of gas increases, its volume increases. So you will notice here on this cylinder with this piston that can move back and forth if needed. Okay, if we keep the pressure the same here, and if our temperature is 200 Kelvin, the volume is 1 liter. But if we increase the temperature of the molecules of gas, that they're going to be going faster and faster and faster, and they're going to be needing more space, and they're going to take up more space. And you will notice when we doubled our temperature in Kelvin that we doubled our volume. So the formula that we need for Charles's law is our V1 over T1 equals V2 over T2. Make sure you write that down. Now then, let's say that if we know 3 of the items and want to solve for the remaining one. So let's say we wanted to solve for the second volume. We could rearrange our formula and say, okay, volume, V2 equals the first volume times the second temperature over the first temperature. So you might want to write that down, either that or just figure that out, but put that down on your list. But what if you wanted to solve for the second temperature instead? Let's say that you had another problem that gave you the first volume and the second volume and the first temperature and said, what is the second temperature? Well, as we rearrange, you will notice as we cross multiply to give and then we divide through to get our second temperature, it is first temperature times second volume over the first volume. So let's do some math about that. First of all, remember, we must use Kelvin. So anytime they give it to us in Celsius, make sure you remember, oh, don't let them trick me. I got to convert that to Kelvin. So a balloon has a volume of 785 milliliters at 21 degrees Celsius. If the temperature drops to 0 degrees Celsius, what is the new volume of the balloon, assuming pressure is constant? So here's our data. We have our first volume, we have our first temperature, and we have converted it to Kelvin by saying that it is 21 plus 273 according to our Kelvin formula, Celsius to Kelvin formula. And our second temperature, which is 0 degrees Celsius, when we add 273 plus 0, we get 273 Kelvin. So now we need to just solve for V2. Well, when we plug in our formula, our first volume is 785 times our second temperature, 273 K, divided by our first temperature, 294 K. So 785 times 273, press enter, divided by 294 is 729 milliliters. Here we have another problem. A sample of oxygen gas has a volume of 420 milliliters at a temperature of 18 degrees Celsius. At what temperature will the volume of oxygen be 640 milliliters, assuming pressure and the amount of moles are constant? Well, first of all, let's think about this problem, first of all. So you'll notice what's happening. We have 420 milliliters, and it is increasing to 640 milliliters. So you know then that our temperature has to also increase. So then we know it certainly then can't be C as our answer. So let's go ahead and plug in our formula, our data. Our first volume is 640 milliliters. Our first temperature, 18 plus 273 is 291. Our second volume is 640 milliliters. Let's find our second temperature. So Second temperature is 291 K. That was what our T1 is when we add 273 to it, times our second volume, 640 milliliters, divided by 420 milliliters, and your answer is 443 K. Well, you go, oh great, I got my answer. No, your answer is in Kelvin, which is fine, but they gave you a choice of the degrees in Celsius, so darn it. Now then, notice how tricky they are. They gave you a choice of A as 443 degrees Celsius. Well, if you weren't looking at your label here, you might go, oh, 443, that must be my answer. No, that's 443 Kelvin. We must convert it back to Celsius. So going from Kelvin to Celsius, we take our Kelvin, 443, we're going to subtract our 273, and we get 170 degrees Celsius, which is the answer B. So let's use the gas laws to complete each sentences with increases or decreases. So press pause and see if you can figure these out. All right, so here we go. Pressure and volume. Well, pressure and volume, if you remember, that was Boyle's law, and they are inverse. So if volume decreases, then we know that our pressure is going to increase. Now, temperature and volume, that's Charles's law, and it's a direct relationship, so when temperature decreases, our volume decreases. Okay, so we have pressure and volume here. Again, Boyle's law, they are inversely related to each other. Notice it's going from 12 to 24, so that means it increases. So the pressure then is the opposite, so that must mean our pressure decreases. Let's look at volume and temperature. Well, that's Charles's law. They are directly related, so let's see. 15 to 45, that means it increased, so volume increases when T increases.